Cool. Well, good morning, everybody. Thank you for taking the time to join us this morning. I am super excited to present Sketchulation basics to you all. I haven't done this sort of thing, certainly not over GoToMeeting, and even in general very often. So I'm going to make a big effort to try to make it worth your while. But do feel free to let me know any critiques you have, any recommendations for how I can do better. Also, as we're going along, I would like you, if you have questions during the presentation, to go ahead and type them in the chat box, and I'm going to try to look for those after each slide. So I think we'll just go ahead and get started. Let me just introduce myself. I'm Mike Korlick. I am a principal at Tipping Structural Engineers. I've been working here for 11 or 12 years now. We're in Berkeley, and I graduated from Berkeley, got my bachelor's and master's a number of years ago. I'm an SE. I've been practicing for a long time now. I started developing Sketchulation about 10 years ago. It's a program that I've written in its entirety, and so any things you like about it, I'll enjoy your compliments. And of course, if there's any complaints you have, they need to be directed to me. So with that, let's go ahead and get started. Oh, I should say also, the program is one that we've been using in our office for structural design. Started using it probably about 5-ish years ago, and gradually it's become the single most used program in terms of replacing sort of hand calculation and spreadsheet sorts of things. So it's one that we use. I think one of the benefits that everyone will appreciate is that we're using it daily. It's constantly being improved. I use it daily for my work, and so we're always adding features, finding bugs, and correcting things, and so I think you'll benefit from that. What I wanted to do today is really just give a very broad overview of the program. For those of you who've been using it a lot, it's gonna be probably a little too basic for you, and I apologize for that. But I wanted to spend the time giving a broad overview, foster your exploration of the program, and pique your interest and spark curiosity for future demonstrations. There's a wide variety of interest and sort of familiarity with the program, and so my goal here is to just give the basics and lay a groundwork and record this demonstration so that we can start to build on it with future more involved, more detailed demonstrations. So we're going to spend roughly 20 minutes on user interface, and then 20 minutes on talking about expressions, 5 minutes on structural analysis and fiber section analysis. Everything is going to be very high level. We're not going to get too deep into anything, and the goal is to be done in less than an hour. And like I said, if you have any questions as we go along, please type them in the chat box. I've got it open off the screen here, and I can answer those as we go along. I also will let you know, like I said, I'm recording this, and we're going to post the video once it's all done, and so you'll be able to review it or let others review it. And this worksheet that we're actually using can be found in the help menu. So first things first, when you start up the program, I think it's always helpful to know that there is help available. There's in the help menu, there is a number of resources. There's searchable help, which is basically just brings up a form, and you can start to type something in the box there, and it will start to search different topics. The little icons tell you whether it's a function or something about a math expression or CAD. And so this searchable help can be useful if you really have no idea what the name of the thing is that you're looking for. There's a user guide in PDF format or in Sketchulation format. So this is the user guide here. It's 100 pages long and has a lot more detail than I'm going to go into here on any particular topic, but it's a good place to look if I mentioned something and you want to dig deeper. There's lots of simple examples that will actually go through a couple of these. And then there are some actually YouTube videos that I've posted in the past. We're going to post this video in this list probably, or somewhere near here, so you can see that. And then there's a list of the commands. These are going to be the CAD commands for drawing stuff and editing things. Operators, these are, math expression operators, plus, minus. It tells you the syntax of how you operate within expressions. There's a functions list. There's a whole long library of functions that are available in math expressions. And this is just an alphabetized list of those things. You'll find later that some of these things, they're limited use because the program is going to give you hints about what you might be looking for. These two things here, assignable properties and taggable properties, we'll talk about this as we go along, but you can tag entities and access their properties within expressions, and so that's what these two things are about. Text tags, this explains some of the special formatting tags that you can put in annotation objects to get things like italics and underlining in Greek. We'll talk about that a little bit more, but that's just a reference there. And then there are a number of reference tables that ship with the program, and you can view those tables if you have a need to sort of understand or refer to what might be in the tables and what the program is looking at. You can find the background data by viewing these tables. And then, of course, if you need to email support, that's me. You can just click this button. If you have an email client, it'll pop up a little email dialog. And I totally love to hear feedback, good and bad. I'll take it. And if you run into a bug, definitely let me know, and we'll correct it right away. And if you do send an email to support, make sure you let me know what version number you are. That's going to be in the About box there. So that's a brief description of help. And now, just diving into the user interface, this is a screenshot. Right now, just to let you know, I'm actually using Sketchulation to make this presentation. So we're in Sketchulation and we're looking at a screenshot of Sketchulation. So it might blow your mind, but I think it's a kind of an interesting way to present here. And going from just around the horn here, we start over on the far left bottom corner. It tells you that this is a command line. Sketchulation is essentially a CAD program, computer-aided drafting program, with a bunch of special entities. That's probably an easy way to think of it. So, it's basically like CAD with expressions, tables, charts, and a way to link up, geometry, lines and shapes and things to expressions. And so as a CAD program, there's a command line. We'll talk about, how that works a little bit in a second. As you're typing into a command line, you'll get some suggestions. In the user manual and sort of in my own way of talking, at times I'll refer to a CAD panel. And the CAD panel is really this whole drawing interface that is basically where you draw, where you select things, and so if you hear me referring to that, that's what I'm talking about. There's a cursor that kind of flows around. You see my cursor is moving around, and then there are crosshairs that you can turn on and off. We'll talk about that in a second. Just guidelines for you. We'll talk a little bit about layouts. You can have multiple layouts in a given document, and that's what these controls are here. We'll talk about annotation scale. Annotation scale sets the size of the annotations relative to the scaled graphical objects. We'll talk about expression systems. That's what these controls are here. You can toggle. One of the features of this program that's different than other programs is that there are two sets of color schemes. There's the alternate, or maybe if you want, the print color scheme that we're looking at right now. And if I click the little button, the circle button with the black and white, it flips the color scheme to maybe what you would like to use while you're drafting on screen. So you have two color schemes that you work with it's basically at your option. A lot of what we do here in the program is using a sidebar editor. So here you see a sidebar editor. This is actually the entity editor for, I have a selected, I've selected a leader here in the screenshot. And there's a tool strip where all the commands are listed. If you don't, or if you're having trouble remembering commands, you're really visual, you can go up to the tool strip and you can pull down a drop-down menu and see little icons for the commands. And then down at the bottom right, the cursor coordinates are always updating as you move the cursor around, just to give you a point of reference. Now, mouse buttons. First thing you need to know when you open the program is that the middle button is kind of like many other programs. If you use the wheel and you rolly ball, it zooms in and out. And if you push it down, you pan. And if you're using a laptop and you don't have a middle button, then there is a pan command. So if I start to type pan, you'll see over here the pan command shows up. And so I can use my left button to pan if I don't have a middle button. But I think it's really important. I mean, for some people, never even, if you've never used a CAD program before, you're not going to get very far unless you use that middle button. The right button has a couple of different features depending on the context. If there's no command active, clicking on the right button just brings up the simple menu to repeat a command or to set the annotation scale and copy and paste, or maybe export an image of what you have selected, or to bring up the properties of whatever you might have selected. And while you're drawing, if you shift and right click, you'll bring up the snaps and angle constraint editor. We'll talk more about that in a minute. And the left button is used for just about everything else. It's used to select something. And if you just click on an entity, you'll select it right away. Clicking on the edge of it or within a text, the sort of bounding box of the text, it selects it. If you click and then there's nothing underneath, then you're going to go into a window selecting sort of mode. And like AutoCAD, if you draw your window from right to left, it's a crossing selection. That means you're going to select anything that crosses that box. And it's a click down, and my finger's off the button right now, and I'm just kind of moving around. And then it's a click again to finish the selection. Now that if I go from left to right, it's an encompassing selection, meaning that I'm not going to select anything unless it's fully encompassed by the box. So you see, I can use that feature to select individual things without selecting others. And also, if you double click on something, it will bring up the entity editor. So I can double click on, say, this image here, and it brings up the entity editor. Double clicking on an annotative object puts you into the edit mode to change the text of that annotation. The keyboard, just a brief overview of the keyboard. The escape key it has multiple functions. If you have something selected, pushing the escape key unselects it, so it basically clears the selection. If you are in the middle of a command, say I start to draw a line and I realize I don't really want to draw a line there, I push escape and it exits the command. And so that's the basics for escape. We use that all the time just to kind of clear the selection and start over. F1 is where you can find searchable help. F2 is a key just to edit annotation. So I have this thing selected, I click the F2 key, and I go into editing mode, similar to like Windows rename a file or Excel editing a cell. F3 toggle snapping. We'll talk about snapping in a second, but just for now, just know that you can click F3 and it turns it on and off. So as I click F3, you look at the bottom left-hand corner, and the snap constraint is either active or not active. F4 is a shortcut to be able to do the same thing as the flipping the colors button at the top. So that just flips between the primary and alternate color schemes. If you have structural models, which we'll talk about later, you can analyze them by clicking the F5 key. And you can toggle those grid lines by clicking the F6 key. So I toggle them on and off, F6. There is a rounding constraint that we'll talk about in a couple of minutes, and an angle constraint. The rounding constraint, you can toggle that on and off with F7, and the angle constraint F8. So we'll get into those in some detail in a minute. There is an expression system explorer that helps you to sort of survey what symbols are defined in your document. You can bring that up with F11, and we'll talk a little bit about expression systems in a bit. If you have multiple layouts, you can page up and page down between the layouts with these two keys, the page up and page down keys. So going between next and previous layout. If you push the control key and you push control A, you get standard kind of things, select all, C copy, X cut, and V paste. And then you can nudge entities by selecting them and pushing the arrow keys. And control nudges them a lot. No control nudges them just a little bit. And if you need to delete something, you can just click, select something and click the delete key. There's also an erase command for that. Okay, so basics about commands. Almost everything in the program emanates from a command. There are a few exceptions to that. But getting to get comfortable with the command line is pretty important. And I think it's probably the most daunting thing for people. Try to make it as easy as possible, but it does take a little bit of getting used to. There's no way around it. So basically, if you want to run a command, whenever you're moving the mouse around the CAD panel, it's active, it's sensing that you're there, and it's ready for a command. So if I want to say draw a line, I just start to type the word line, and then you see a list of possible commands comes up. And the more I type, the more that list is going to be narrowed down until to the point where only things that have the word line are going to appear. When a list is populated, if I hit the enter key, then it's just going to take the top item in the line. Otherwise, I could just click on a command if I see what I want in the list, but it's not the top one. I can draw, say, a linear dimension by clicking that, and it can draw that really quickly. I encourage you to memorize the shortcut keys just to minimize the amount of typing that you have to do. They're listed in parentheses next to the commands. As you hover over a command, you can get tip text that shows up next to the list there. That might help you discern whether you're getting the thing that you want there. Now, after you've run a command, if you just want to rerun the same command, you can just hit the enter key, and it will rerun the command that you ran last. Let's see. If something is selected, everything I just said is in the context of nothing being selected. If I have drawn a line and then I select it, and then I start to type something, in addition to commands, I will also get quick access to properties of that line. We'll talk about the property editor in just a second, but this is a way of getting access to a particular property of the line without having to bring up the entity editor. So I can change the thickness of the line very quickly that way. Now, I mentioned a second ago sidebar editors. Sidebar editors are the way that you're going to edit both graphical and non-graphical objects in the program, editing properties, things about the entity that are not sort of geometrical. So, you can change points and things by dragging the points around. You can move things, graphically using the mouse. But let's say if you want to access the property of a line, say it's a layer, or like I just did, the thickness of a line, you'll want to go into the sidebar editor or do this quick property editing. In the sidebar, there are a number of sidebar editors that are used in the program. There's the layer editor, the text style editor. The most common thing we're going to use is the entity editor, and they have a lot of similarities that you want to be aware of. You can filter out certain properties that you that you might want to find. So if I have a line and I go here and I type MO, which is the command to bring up the modify properties entity editor. Here is the entity editor for that line. And let's say if I'm just looking for the thickness, I start to type thickness and it filters out all the other properties. And so I can very quickly get to what I'm looking for if I have some hint of what it is to begin with. And again, like I mentioned, there's a lot to learn. So the more experience the more you use the program, the more you'll gain experience, and you'll get quicker at finding these things. The sidebar editors have these little buttons that where the groups of properties can be collapsed or expanded. And by clicking Control and clicking a button, you'll expand or collapse everything. Again, to just try to help you dig in and find what it is that you're looking for. And lastly, you can see the properties of entities in table view. Let's say you have multiple entities selected. I can click this table view button, and now I'm seeing the properties of those three entities in a table view, which makes it possible for me to paste multiple properties at once, say replace all that text all at once. So that's quickly about the sidebar editors. Now I haven't seen any questions yet in the chat box, so I'm going to keep on going. But if questions come up, please feel free to go ahead and pop them in the chat box, and I'll answer them. Entities. So entities is basically the word that I use when I'm referring to graphical entities. And you see, this is a list of all the entities that ship with the program. One of the cool things is that it's always kind of expanding. We're adding entities all the time. We have a lot of the basic entities that you've probably seen before: lines, arcs, polylines, splines, that kind of thing. We have a spline shape, which I don't know of anybody else who has a spline shape, so I still have yet to really use that, except for just for fun. We have text. There's another version of multi-line text or multi-layout text for maybe doing like a long report. Leaders, dimensions, clouds, cut lines, curly bracket, rough line, and then we have some things that are kind of more special to us. We have cross sections. We have rebar in section and also in elevation. You can define blocks in the program. You can insert images, and the images can either be referencing a file or they can be embedded in the Sketchulation file. Sorry about the fire truck. We have viewports. So this is a viewport actually looking at the entities on the left there. We have hatching. And then there's more stuff that I just kind of ran out of space here, but things like expressions, charts, tables, and frame elements, things associated with structural analysis, loading, and things like that. And we'll chat a little bit about that in a minute. So I thought now would be a good time to just illustrate a little bit of drawing and zoom in on this one slide here. Just illustrate how the command line works and just some of the step-by-step directions that you'll see. So I'm just going to draw a simple line. I type, like I said, I search type L. I know the shortcut key for line is L, and so I click enter. And now you'll see at the bottom left-hand corner, you're going to get some directions, step-by-step directions from the command line telling you what to do in case you forget the steps. Some of the commands are somewhat complicated, and you'll have to refer to those. Even I refer to those sometimes because I forget some of the steps. So it's telling me to select or enter the first point. Now I can start to plop down that point, and you'll notice now it's telling me to select or enter the next point, or enter U to undo, R to toggle rectangle, or T to set the thickness. Now, one of the things I want to point out is that if you want to use one of these in command options, you do not need to push the enter key. You just press the character. So if I want to undo that point, I click U, and it undoes the first point that I drew, and now it's asking me for the first point again. Let's say I want to set the thickness of this line. I click T, and now it's asking me for a distance. I'm going to set the thickness, say, at 12 inches. The drawing has units of 12 inches. Those are embedded. They can be changed in the options sidebar. But I can just enter 12, and it knows that it's inches. And so now my line is 12 inches thick. And if I click R, toggle rectangle, now it's displaying this line as a rectangle. It's just a special feature of a line. Now you'll notice that there are little guidelines emanating from the first point where I started to draw the line. That is the illustration of the angle constraint. So angle constraints basically force you to draw along fixed angles. And again, that you can toggle that on and off using the F8 key. So I just turned it off with the F8 key, and you'll see that the message down at the bottom telling you that it's just been turned off. Turn it back on, F8. Let's say you want more angles or fewer. You can shift and right click, and you'll see down at the bottom you can select an angle interval. I have 45 currently selected. I could select 15 degrees, and so now I get a bunch more in nuance in terms of the angles. I tend to leave it at 45. So now I'm ready to draw a line. Let's say I want this line to be 15 feet long. When you're in the midst of a command, you have the option of just entering a distance or picking a point. If you enter a distance, it's going to go along the guideline, or it's going to go to the cursor if you don't have the angle constraint active. So I'm going to make a line that's 15 feet, designate feet with an apostrophe, and then now I've drawn a 15-foot long line. And just to verify it, I make a dimension, and now by default, this dimension is always going to be measuring along an orthogonal axis. I hold the control key down, and now it's going to measure along whatever point I pick. And I'm going to snap to the end point of the line. You see, as I'm drawing here along the line, you'll see that it's lighting up yellow, and it says nearest in little letters, little yellow letters there, greenish letters. And right now it's snapping to the nearest. It's going to sit right on the nearest point of that line, nearest to the cursor. If I get close to the end, it's going to snap to the end point. Again, this is illustrating object snapping or entity snapping. If I right-click and shift right-click, you can see what the snapping options are. Right now, I have many options active, shown here. All of the possible snaps are working. If during a particular command you only want one snap type active, you can click it here, or you can memorize that shortcut key. And if you click the shortcut key again, you do not have to push enter. So I know it's E. I'm going to hit E, and now at the bottom it says snapping to endpoint. And now, regardless of where I am on the line, it's going to snap to the nearest endpoint. And so that just shows that I actually did do a 15-foot long line. There are lots of snaps. I encourage you to investigate them in the user guide. One thing I would point out are these fancier sort of snaps where you can offset from a base point. Say I want to be 10 feet away from the end point of the previous line. I can click this one, B base point, and now it's telling me to select a new base point. I want the end of that line, and then I'm going to go over 10 feet, and then it drops it right there, 10 feet away from the previous line. So that's base point mode. Now, so I've illustrated the angle constraint, snapping, and one other constraint is a rounding constraint. Let's say you want your line to be to the nearest 12 inches. You can set the rounding distance to 12. It happens to be 12 inches already. And now by toggling it on and off, F7 will toggle on and off this rounding constraint. See, now if I have it off, it's nice and smooth. If I have it on, it jumps. It's going to be set at increments of 12 inches. So I can make a line that is rounded to the nearest foot, like that. All right, moving on. Still no questions? Let me know if you have any. Editing entities. So on the far left here are two actual entities, and these guys here are images, screenshots from previous, from yesterday when I drew them up and took snapshots of them. So to edit an entity, one of the most common and useful ways to do it is by its grips. The grips are these little blue dots at certain important nodes of the entity. This is a shape entity. I happen to make this one segment an arc by doing the set arc segment command. So set arc segment, SAS, and that can toggle that on and off with for shapes and polylines. A few things kind of work that way. So if I have a grip highlighted, that command is active on that one grip. I can also grab that grip. I can click on it. It's now selected, and I can click on it, and I can move it around and stretch this entity if I want. I can select multiple grips and stretch them around. And from the grip editor, I'm using stretch now, but if I hit the enter key, it cycles through other commands like move. So this would be a translation, or rotate, or scale. I can enter in here a scale factor, or basically do scale by reference. Let's say I want to scale something, I could click reference here, R for reference, and now it's asking me for a distance. So now I can scale that thing basically from the previous distance to a new distance that I would pick. So these are examples of grip editing. There's also a whole number of other commands for editing. There's moving or copying, rotating. There's basically commands for just about anything you can possibly think of. And if let's say I want to make a copy of something, a rotated copy, RO for rotate, and as I'm rotating this entity, maybe I want to make a copy of it. Down at the bottom, I see it says C for copy. So I click C, and now it's going to make copies as many as I want. That's kind of getting messy. So, and now I can select them, carefully not get the image, and click the delete key, and then they're gone. Now, entities, every entity has what's called a layer. Layer controls how the entity looks. I can bring up the layer editor, command LA, and you see this particular entity is on this layer called annotations. I can change its layer. Maybe I want to put it on a different layer. How about I put it on S concrete heavy? I can click this paintbrush and it'll apply a different layer. Again, layer controls different. The layer controls the appearance of the entity, the thickness of the line. There's different colors that you can choose from, different line types you can choose from, all sorts of things that you can do with layers to group things together. The program offers layer palettes, so you can define palettes. You know, oftentimes we develop documents that have both calculations and drafting, and we might want to separate those things out. So you can filter out just calculations by creating a palette. I'm not going to get too much into that. Just want you to know it exists. Similarly, text objects, they have what's called a text style. So you can assign different fonts to text objects by basically choosing their style. This one happens to be assigned the default text style. Let's say I want to put that on the title text style. I select the one I want, click the paintbrush, and it applies a new text style to this text object here. So text styles and layers, just a little touch to let you know that it's there. And if there's more interest in that, please let me know and we can dig in further. Now, I thought it would be good to really just talk briefly about setting up a document. When you are about to start a new calculation, it is helpful before you get too deep into it to think about where it's going. So I have some guidelines here that I think are important to do. We're gonna make a new document. We're gonna bring up the print dialog to set the paper size. So I click new, and this is what you're gonna get when you click new, is just a blank black screen. And so you really want to figure out, set the sort of the boundaries of your document from the get-go. And so I'm going to click Control P. It brings up the print dialog. It has, of course, our logo on it, which is totally customizable. You can put whatever you want in the header and the footer and position these things and set the margins and set the paper size. That stuff is all described in detail in the user guide. But the key thing is you want to make sure you got your paper size and your margins and everything the way that you like them. And so that sets up the printable area, which is the area of the paper excluding the margins. Once I've set my print area, I'm going to plop on a page. I start to type page, draw page, PRD, and it doesn't really matter where we want to put it. I'm just going to plop it in this particular place. Now, what you want to do is start to sketch out what you're going to have in your document. So here, let's say I have a shape. Maybe it's the floor plan. And let's say this floor plan looks something like this. This is my floor plan. I'm just messing around. And I sketched this out, and then I put in some text just to start, kind of get a sense of what I'm doing here. Building plan. Okay. And I find that with my document, with my building plan and my text, nothing is fitting. I find the paper is too small. And so the question is, what do we do about that? Well, you could go back into the print dialog and pick a bigger paper size, or better would be to set the annotation scale to be larger, because if you really need to fit it on 8.5 by 11, that is your only option. So as I change the annotation scale, what it does is it makes a correspondence between text size and the paper size with the actual drawing to scale in your document. So this one looks like it needs the paper to be maybe twice as big. So I'm going to use an annotation scale of 200. And notice the paper got exactly twice as large because we went from 100 to 200. The text also got twice as large, but the graphical object did not change. And the graphical object's dimensions are fixed regardless of the annotation scale. This happens to be 92 feet 1. And it's the text and the paper that are going to be changed. So once you've sketched out what it is you're going to be calculating, and you have a mock-up of the text that you're going to add, you're pretty much ready to go. You can copy around more pages if you need to. Let's say I'm going to make a few more pages here. Maybe for some reason I want to tile them down. So this is maybe my overall document. I've done a number of things on this document, and I'm sort of ready to print it. So here you need to set your print extents. I'm going to start to type print area, shortcut PA, and select the extents of my document. And you'll notice the program automatically detects if there's going to be an empty page, and it doesn't include that in your document. So if you want an empty page, actually I'm just thinking of that the first time, you might need to put like a white line or something to make it actually create an empty page for you. But here I have a document that's sort of laid out and ready to print. Now let's say on one document you have two different annotation scales. The only way to deal with that effectively is to create another layout. So let's say I have a building plan on the same sheet that I'm going to want a detail. So I would make a new layout, and maybe this new layout is going to have scale 1 inch is 1/2 an inch is equal to a foot. So that's scale 24. So now I have a new layout. I set the annotation scale here to 24. And let's say on this detail, I'm going to have a concrete beam. So there actually is a command for creating a concrete beam. And let's say you can look into these options later, but let's say my concrete beam is going to be a big one. It's going to be 24 inches. So type at, which is basically going to reference the point that I have selected, 24 x, so it's 24 in the x direction, 24 inches, and 36. And this is my concrete beam. Now I want this concrete beam to appear on the previous page. I'm going to make a viewport, VP right there, draw the viewport. Okay, let's say I don't want this viewport is now it's viewing the concrete cross section that I drew over here. So if I draw this line here, it shows up in the viewport over there. Now let's say I don't want that outline to show. There's just an option to turn off that outline. I click it here and say no. And so now this is my viewport. I control X, I'm going to cut that thing out of there. I'm going to go back to my plan, paste it on here. Now it's super small. I need to scale it up by the scale. The scale factor will be the ratio of the annotation scales. So in this case, it would be the scale 200 over 24. Notice I can enter in math expressions right here in the command line, and it'll figure that stuff out. So now this is my cross section. It's at a different scale than the plan drawing here, and I can have them appear both on the same sheet using a viewport. If I double click on the viewport, or if I click this little thing here, it's going to take me to where that viewport is looking. And maybe I go in here and I put my dimensions on that because I realized I forgot them. I really wanted them. Okay, now I go back. Again, you can page up or page down to go between layouts. I'm just clicking the page up key. And you see my viewport kind of cut off the dimensions. So I select those grips and stretch them a little bit so I can see more of the viewed area. And there we go. So that's the basics of setting up a document. Okay. Let me know if you have any questions. Okay, so expressions. We're breezing through a few different things here. Expressions are basically fancy text objects, text entities. There are two types of entities that work with expressions. There's the expression text, which is like what we have here, and there's an expression leader, which is the same as the text, except for it has an arrow attached to it. Now, when you start to draw an expression, by default, it's going to be on the layer. It's going to be colored with the layer that it's on. And these things can be overridden in a couple of different ways, and we'll talk about that in a second. But here is one expression that I've entered. I just typed XT. I plop this down, and I start to type. And the syntax is simple, just like you would do in Excel. And as I type, it's going to enter the numbers that I type. But if I do something that is sort of like mathy script, it's going to automatically format these things in a math script form. And so you see, you know, as I keep going, if I add an exponent, it puts these things in the layout that you'll like, or that you want it so you can discern it. Now, one of the things I mentioned here is that if you are struggling to see all the characters or understand how this expression is actually written, you can reveal hidden characters by pushing Control P. And when you do that, you have the math script rendered on the top, and then you see the literal text that's been entered on the bottom. So that can help you debug if you see that there's some hidden characters and you're trying to figure out what's going on. So Control P is a pretty important feature to remember. I just toggle it on and off as I need to. Now, once I've defined a variable, like in this case, I defined the variable x, I can refer to it in any other expression, regardless of where that expression is going to be located. If you want to have a Greek character, you just put a little tilde in front of the character, and then it renders it as Greek. You can put subscripts by pushing the underscore and enter in a character there, and everything after that is going to be also subscript. Now this expression here defines y. Now let's say that I want to run the same calculation for y, but with a different value of x. So if I go over here and I start to type xt and I say x equals 2, watch what happens. This expression comes out with a question mark. It doesn't know what to do because it's ambiguous. There are two versions of x. Now if I hover over that expression, it will actually tell me that that's the case, that there are multiple assigning expressions. And in order to resolve that, you have to know about expression systems. So expression systems are basically, they are a construct that allows you to keep an environment separate from another environment where the variables in each environment will be unique. So what I mean by that is you can have two different expression systems with the same variable names, and they can be evaluated independently of one another. So I need to put this x on a different expression system so it doesn't interfere with that x. Now currently the expression system that is active is this one called global. That's the default, it can't be deleted, and it's always going to be part of the document. And I can make a new one like I've done here by clicking this button, add new expression system. I click that and it brings up this dialog. I've already made one, so I'm not going to do that again. But now I want to put this expression on this other expression system. And here's where the overriding the layer colors can be very helpful. I type XS and bring up the expression system editor, and I see I have two expression systems defined. And if I want to know which expressions are on which expression system, I can override the layer colors by clicking this checkbox, and I see they're all black. They're all corresponding to global. Now I want one of them to be on this XS01, so I select it, and then I click the paintbrush, and I go and select the expression that I want, and it changes it to a different expression system. Now the ambiguity is resolved, and so this can evaluate, and I now have a different expression system with its own independent version of X. Now let's say I want to run this calculation for Y with this version of X. I need, I'm going to make this expression system active, XT, start to type Y. Now I could, at this point, I could retype that entire expression, but I don't need to. If the expression itself is defined as I like it, I can simply type Y and then this operator here. This is a dash and then a greater than symbol, which basically requests the value. And in this context, it's going to evaluate Y using this expression system or this expression, but inserting this value of X. So this is a fundamental concept that really makes the program quite powerful. You can, in this case, every expression system except for global inherits from global any expressions that are defined in global. But as you have more expression systems, you can actually make them inherit from different expression systems, so that you're really minimizing the number of locations where you're defining expressions, and that way avoiding error. So I have a question. Can you define different page sizes for the same Sketchulation file? The answer is yes. Going back to my previous example, this sheet here is defined with 8.5 by 11 paper. I can go in here, I can insert a new page on this layout, and I can change that paper size to 11 by 17. The paper size is defined by layout, and you can see layouts in general. There's a layout editor. If I type LO, I bring up the layout sidebar editor, and then you can see all the options that are available for for all the layouts, and you can see which ones are on which printer settings very quickly this way. So thanks for that question. Okay. Okay, so now an example of expressions, an actual worked out example. So here I want to illustrate expressions. I'll show you a little bit about charts, tables, and tags, and units. I should say that expressions do keep track of units for you. It's one of the powerful features of the expressions. You can enter in units in the expression, and they will be kept faithful. I'm going to go into help. I'm going to pop open this example called base shear. This is a worksheet that defines the base shear coefficient, calculates the base shear coefficient for a particular building. You probably are all familiar with these sorts of things. In here, you see we're defining these basic accelerations, and we're calculating the FA coefficient. There's a special function called getFA, and so this is a function within an expression that we've written, and it's actually looking at coefficients defined in ASC 716. As you're typing in an expression, you will get help. So in the context of being inside this function getFA, it's giving me hints about what type, what it's looking for. On the top, that's where the hints are going to be. On the bottom are suggestions about about what you might want to insert. So, for example, if I'm going to type an expression over here, x equals s, it's going to populate a list of suggestions with all the symbols that it finds that start with S. So that makes it simple to not have to type so much. And if I click Tab, it will complete that phrase. and go ahead and I can request its value that way. Another thing this illustrates is at the end of the expression. This is the request for value operator. You see the operators for more explanation on that. And then this is a delineation of a comment. So everything following that double slash is a comment. So that will be explained in the user guide in more detail. You can also do a prefix comment. And I noticed there's something wrong with my document. This expression is obscured, and I want to relay that out. So the quick way to do that is to select all this text and type the command space annotations. And I go and I find it here. It's the third one on the list. SPC is the shortcut. And watch what this does. I click this, and it aligns all the annotations and then spaces them so that everything's showing. So I corrected that. This expression here is querying from a column, from a table rather, and we'll get to that in a second here. So ultimately, we calculate the base year using this this worksheet. There are special functions like the select function, if function, max, lots of things that you would expect. There's arrays that you can define in the program and work with arrays and vectors and things like that. Here is a chart of the response spectrum. I'm not going to dig into charts at all. I think that's a subject all into itself. But just so that you know, you can do a really elaborate charting. You can chart table data, expressions, special grid lines. You can add point labels. You can set specific colors to specific dots depending on little fields that you have to enter. So there's a whole bunch to learn about charting. I'm just going to show that it's there, and you can kind of explore that in the user guide or in this example. Now this is a table. I haven't talked about tables yet. You can insert a table by just typing TBL. And tables are similar to spreadsheets in some ways and very different in others. Essentially, a table is set up with a bunch of columns, and the column header is a really important part of the table. So you see here I've defined this expression, this variable LF sub 0, and it's set up as 1.125 feet. So that is the units feet. And then I have this expression here that I've called HX is equal to LF minus LF 0. Now this expression outside of the table makes no sense because the value LF isn't defined anywhere. But within the context of the table, it can be evaluated. So you'll notice as I double click into the table and I go into edit mode in the table, I can select this column header, and you'll notice that there's a little globe there at the top right-hand corner of the column header. That tells you that this header is referring to an expression that's defined outside the table. In other words, it's defined by this expression here. So when I go into the table and I want to calculate the value of HX for each floor level, I simply type in the text H underscore X, and it knows to go and look outside the table. First, it looks inside the table to see if another column is defined in that manner. And if it doesn't find that, it looks outside the table for the definition of that expression. And then each row of the table is evaluated as though it's in a separate expression system. So for example, HX on this row is defined using this value of that variable LEV. And so it comes up with 15.9 on this row. Whereas on this row, it's using this value for LEV and comes up with a different number. So the table has the ability to take a set of template expressions that are defined outside the table that are typed only once, and it can absorb them inside the table and evaluate them differently on every row. And what this means is you can really limit how much error you have in a document. You can make it very clear how the table is coming up with its values. You can debug, whether there's an error in a certain equation because it's all defined outside the table. You can tell right away that a table is defined by, or the values in a column are defined by an expression because they're grayed out. So these two columns that are gray are being defined by the header expression, whereas this column and this one are hand entered. Now, a short bit about tagging. I've drawn a plan of my building. This is my typical floor plan, and this is, I'm sorry, this is the level 2 floor plan. This is the typical floor plan, and I've given them what's called an entity tag. So if I click on this and I type MO for the modified properties, I can see that this has been assigned this tag here, shape typical floor. Now, I can use that tag and I can refer to it in an expression, as in here. This expression is going to calculate the area by looking at the value of level. So it's going to be we're thinking of this table right here where level is typed in on the far left. And the area is calculated by looking at the shape, the tag that's listed there. So if the level is LO2, it uses this shape LO2, and then the dot tells you to look for a property, and then area is the property name that you're looking for. And similarly, if you're not level 2, then you're looking at this other shape and getting its area. And so you see in this table here, A is the global expression that's defined up here. And so all these areas are being calculated based on this template expression. So that's just a little bit about tagging. There's a lot to learn about tagging. Again, it's a subject all to itself. Now a tiny bit about units. You'll see I'm calculating at the end of all this, I'm calculating the base shear, and it comes out by default in kips. Let's say I want it in pounds for some reason. The way that can be rendered is I simply go in here, there's a request for value operator, and I can type in any other units that I want, say kilograms, and then I want it in, say, or maybe newtons or kilonewtons. This is the way that you can render an expression, the result of an expression in different units by simply putting in the units after the request for value operator. And here are some more charts that I don't have time to go into at the moment. This is a really great example to kind of dig into and start to learn more about how these expressions work. Now, a brief example on structural analysis. And I know I'm running a little short on time, probably going to go a few minutes over, but I hope you can stay and listen to this. I'm going to bring up another example that ships with the program called Simple Beam. And this is it. I'm going to go ahead and just erase everything that's here just so I can walk through the process. And I'm going to clear out a couple of things here just to set myself up. Okay. If I push Control while I push this little X button here, it closes all the editors at once. So I've defined some expressions here that I think probably are pretty, you should be able to understand them at this point. These define the loading for a particular beam that I'm going to basically analyze. The command for the drawing a beam is FE, frame element. I draw this, let's say it's 30 feet long. And so now I have a beam. I'm going to define that beam, but give it a frame element type. So as I know that's FET, so there it is, frame element types. And I have a W18 by 40 already defined, but I'll show you how that works. In this editor, I click New Cross Section, and within this, there's a robust list of things that you can do, things that you can choose from. You can choose an AISC standard shape, ACI, which is going to basically use a fiber section, or NDS, wood eye joist, or rods. What comes with any of these decisions is all the standard code checks. So you'll see later on we get to a DCR calculation, and it's going to use all the standard equations in order to come up with that DCR, and you can double check that later. So I'm going to pick AISC for now. I can define a custom shape, which is a custom common shape, like one of those, or I can grab one out of the database, say W18 by 35, for example. And once I've selected that, I just click in the empty CAD panel in order to define it and finish off the definition. And so now I'm going to paint that onto my frame element. And now if I click override layers, it will show me the color of the frame element's type. So I've got that 18 by 35. I can also start to type label. I can make this label also show what that frame element is, how it's defined. Now I need a couple of restraints, RES. Put in a couple of restraints like that. I'm going to have some linear loading. Put that in there. Okay. Now linear loading, you're gonna enter the linear loading also as an expression. In this case, I'm going to make that my dead loading. Now I'm going to copy that loading. I'm going to click on this little grip here. This stretches this loading around. It's just graphical, so I can put multiple loadings on the same beam. And I'm going to click C for copy. It's going to make a copy of this loading, and I'm going to stretch it up there. And now that's going to be my live loading. Okay. Now I've got dead and live load. And let's say I have a point load, PLD, and I'm going to give that this expression P underscore D. Okay. So I've got some loading on there, and now I need to make my load sets and combinations. So load sets are going to define the type of loading a particular load is. So I could define these as this would be like dead or live or earthquake. And then I'm going to need load combinations and ultimately load sequences, which I'm not going to explain really in detail at all today, but you're probably all familiar with load sets and sequences. It's a bear to make all these by hand. Unfortunately, there's a little button to macro create all these. You can go through this later and kind of see all the options. I'm going to select all these load combinations and click OK. And so now it has created all my load combinations and all my and the load sets that it needs to. I'm going to assign a couple of things to dead load, which is this point load and this linear load. And you see this is already overriding colors, so I can see what's what. I'm going to set this other one to live load. And so now I have a model that's fully loaded. Now if I want to analyze this model, I would bring up the analysis options, structural analysis options editor. And you see it's already analyzed. It's on auto analyze. Basically the program can analyze on the fly anytime you make a change. So this model has already been analyzed. I can highlight it by clicking on it in the list. Helpful if you have multiple models. And you can view results right here in this mode, but the better thing to do is to use a command called viewport model. Shortcut for that is VPM. I just start to type VP, and there I see it there. And the viewport model command is going to make multiple viewports of this structural model, and each viewport is going to be looking at a different aspect of the results from that model. So I will select a viewport that sort of looks like this, and there's a bunch of options here to choose from. These are pretty standard ones. You're going to get the DCR, deflected shape for all the ASD loads, moment and shear diagrams. I click OK, and it's made these viewports, and I'm just going to position them right there, and I can scale them, or just click Enter to keep the scale matching the actual model. And so here I have these various viewports. Each one is illustrating a different result. They're all looking back at this model and telling me different results. And you see, I can see the deflected shape for all the ASD loads. I can see my DCR really too high, and the moment and the shear force. Now, one really important thing to be aware of when you're doing these DCR checks, especially with steel, is that the unbraced length has to be set properly. So I'm going to go into the entity editor. I'm going to go and find that unbraced length. You can read up on what all these things mean. There's a little helpful image that you can bring up and kind of see how the axes are defined. But I know I need to have this this thing braced, say at 24 inches. And you see now my DCR becomes correct. Before it wasn't working because of lateral torsional buckling or something like that. Okay, so that's a brief just touch on structural analysis. Lastly, I wanted to just spend a minute and show what you can do with fiber sections. I'm going to bring up another example, concrete moment rotation, concrete column moment rotation. So here I've defined a shape. You can actually draw a column like I mentioned before using this command conc call, and you can set these things up very quickly. So I just drew that column right there, and once you have the shape drawn, you need to define materials. Bring up the fiber material editor, and so this shape has been assigned a material called F prime C equals 4 KSI. Again, I recommend that you read through this carefully and kind of get a better understanding of what's going on. But basically, we've assigned this particular material, this particular outline. We've assigned this F prime C 4 KSI, an unconfined concrete. This part is a confined concrete, so it's confined core, and then this one is assigned the rebar. Now, then we have a bunch of built-in functions where you can get results for this cross-section. This cross-section is tagged, like I mentioned before. I talked a little bit about tags. So I've tagged that cross-section with this symbol BM. And I can get the moment rotation curve for that cross-section. And what's happening under the hood is that this cross-section is being meshed, and it's running a fiber section analysis for you with sort of standard meshing, and it's returning that to the function. Now, as I just showed, you can bring up a dialog to dig more deeply into the analysis by selecting the cross-section, and there's a couple different commands to enter there. MR, moment rotation, or say PM, brings up the PM diagram, and all these things can be edited. You can within this dialog, you can find the moment rotation or the moment graph for this particular cross section. So some of the really cool things you can do with this is you can plot reduced capacity. You can click a point and you can go along the PM diagram, and on the right you can see the colors changing as you go along. I'm just clicking the arrow keys as I cycle through the PM diagram. You can set how much axial force, well, this is a PM diagram. In a moment rotation diagram, you can set how much the axial force would be. So let's say I have, I don't know, like 400 kips negative is compression. And let's say I want this to go to a larger rotation. I click Analyze, and now I have the two moment rotation curves on one graph, and I can click between them. I can select a fiber and then see how that fiber is behaving as I go along the graph. And so there's lots to do with that. You can zoom in and out and things like that, and take a screenshot and paste it in. So brief touch on that. And with that, I'm pretty much done with what I thought I would go through. Sorry, I'm about 10 minutes late now. I'm happy to stay as long as other people are willing to stay and have questions. But I do want to say I'm going to put out a post-demonstration survey. I'm going to email it to all the invitees. And I would love your feedback. I'd love to know in particular what other things you would like me to dig in deeper on. I'd love to know if there's any feedback on the presentation itself. And if there's features you want to add. And certainly if you run into bugs, let me know right away and I'll correct them. My email address is there, m.corlick at Tipping Applications, or m.corlick at Tipping Structural. So with that, if there are other questions, you can type them in.